Boys and girls, now let's do example number 2, homework number 3. Worksheet 10G, proving identities. Let's do number 1 and number 5 as example.
Right, the first question, prove the following identity. Prove that the right hand side is equal to the left hand side. Right, firstly we're going to look at what is very important when proving identities. Right, we have a list of what is important here. Right, when proving identities, please change a complicated side so that is equal to the other side. And then if you check there, the complicated side is the left hand side. Now we're going to change the left hand side so that it looks the same as the right hand side. Secondly, don't rearrange. Right, we're not going to rearrange by applying inverse operations here. We're simply going to simplify the left hand side so that it looks the same as the right hand side. Always change the tangent of theta into the ratio of sine and the cos. So whenever we see tangent, we're going to think about the ratio of sine and cos so that we find very easy to simplify. Right, LCD. When there is addition or subtraction of fractions, for example, this one, if you can see here, we have two fractions and we are adding. Then we're going to use the LCD. We're going to find the LCD and simplify. Right, another, the last thing, factorize. Factorization, whenever we see plus or minus in fractions, for example, we are given these simple fractions. This is the knowledge of algebra. So if you are good in algebra, you're going to find the whole thing very simple. Please practice algebra. Now let's do this first example. Let's start with the left hand side. The left hand side is equal to sine theta divided by 1 minus cos theta plus sin theta divided by 1 plus cos theta. Now we are adding fractions. This is the complicated side. We're going to find the LCD. The LCD from algebra, you know exactly how to use the LCD. The LCD is 1 minus the cos of theta into 1 plus the cos of theta. Right, now we're going to multiply each term by the LCD. Then we're going to find the first term will be sine of theta into 1 plus cos theta plus the second term will be the sine of theta into 1 minus the cos of theta. Right, now we go into distribute here. Sin theta plus sin theta cos theta. Distribute the sine of theta to each. And then plus the sine of theta again. Minus sine theta cos theta. All divided by. Every time when you simplify, check what you are trying to satisfy. If you check the right hand side, the denominator is only one function. Now let's try to work out this. This is the binomial by binomial that leads us to the difference of two squares. This is 1 minus cos squared theta. Right, now let's add like terms. 2 sin theta will be the result. Sin theta cos theta minus sin theta cos theta is 0. All divided by, now 1 minus cos squared theta can be changed into the sine squared theta. Remember, we are trying to satisfy this. The denominator is the sine of theta, but we still have cos. But this can be changed to sine squared theta Then now we're going to divide. Divide, then the answer is 2 over the sine of theta. Therefore, we can conclude by saying the left hand side is equal to the right hand side. That's it. Right, the last examples on how to prove identities. Prove that the left hand side is equal to the right hand side. Now, if you can see here, the left hand side is the one that is complicated because the tangent of an angle can easily be changed into the ratio of sine and cos. So we can find sine cos out of this. Right, let's continue. The left hand side. The left hand side is equal to 1 minus, then we're going to change the tangent into the ratio of cos and sine. This is the sine of x divided by the cos of x, divided by 1 plus sine of x divided by the cos of x. Right. When we continue, we can see that we have fractions and we are subtracting. I told you whenever we see fractions and we are adding or subtracting, LCD. Now the LCD from the numerator is the cos of x. Cos of x is the LCD. Then we're going to multiply each term by the LCD. The first term, cos of x. This second term, minus the sine of x. All divided by. Again, we are adding fraction plus 1. We're going to use the LCD. LCD is the cos of x. Cos of x is the LCD. Then we're going to multiply each term by the LCD to find the numerator. Cos of x multiplied by 1 is cos of x. Then multiply by the cos of x by this whole fraction. So what do you get? The sine of x. So we have a fraction divided by a fraction again. Now we're going to change this fraction into a multiplication. Cos x minus the sine of x divided by the cos of x. Then now we change this division into multiplication because we have a fraction divided by a fraction. This will lead this one into cos x divided by cos x plus the sine of x. Now we are allowed to divide. We can divide these two. Equal to cos x minus the sine of x, all divided by the cos of x plus the sine of x. Now, remember, I told you to always look at what you are trying to satisfy. Now, we arrived here, and you cannot cancel when we have plus minus between. But now we want this expression to look the same as that one. Right. If you can see here, we don't have squares, but there we have 1 minus sine squared x. And then down there we have sine x cos x. Then now we're going to multiply by an expression such that this is formed. Right. The expression that we're going to multiply by is cos x plus sine x divided by cos x plus sine x. This whole thing is 1. If we are multiplying by this, it's not going to change anything. Like, for example, let me give you an example with numbers. Let's say we have 1 over 3. 1 over 3 is the same as 1 over 3 multiplied by, for example, 4 over 4 is the same. So that's what I did. But the aim of multiplying by this is to end up forming what is displayed on the right hand side. Right. Now let's continue. This is binomial by binomial that leads us to the difference of two squares. When you continue, this is cos squared x minus sine squared x, all divided by, this one is a binomial squared, cos x plus sine x multiplied by another cos x plus sine x. You know how to work out binomial squared. This will be cos squared x plus 2 sine x cos x. Then the last term will be sine squared x, binomial squared. Algebra is very, very important. Now let's continue. But now we have cos squared x, sine squared x. But what we want to satisfy, numerator does not consist of cos squared x. Now we're going to change cos squared x using square identities. Equal to 1 minus sine squared x is cos squared x minus sine squared x, all divided by. Now we're going to add cos squared x and sine squared x. Remember, cos squared x plus sine squared x is 1. 1 plus 2 sine x cos x. Now we're going to add like terms there. 1 minus 2 sine squared x, all divided by 1 plus 2 sine x cos x. This is the same as the right hand side. Now we can conclude by saying, therefore, the left hand side is equal to the right hand side. That's it. Please try the next activity.